All right. Looks like we've got most people here. People are still trickling in, but that's okay. So I'm going to go ahead and get started. So today for Webinar Wednesday, I'm going to be talking about creating shrink wraps in Creo. I'm going to talk a little bit about what shrink wraps are, what they are used for, and some of the different ways to make shrink wraps. And lastly, I'm going to demonstrate how to do that. So here we have the agenda for today. Essentially, I'm just going to give a little introduction about Boundary and myself before jumping into shrink wraps, talking about them, describing how they can be used, demonstrating, etc. One thing to mention, if you have any questions, there is a question pane in the GoToWebinar settings panel type thing. So one of the drop downs is for questions. So if any of you have any questions throughout this webinar, feel free to just put them down, and I will get to all of those questions after I'm finished. So a little bit about me. My name is Sebi Beaver, and I'm a technical specialist here at Boundary. I have a mechanical engineering background and lots of experience with different CAD software, starting with AutoCAD and SolidWorks and moving into Creo. Additionally, here at Boundary, I am working on and kind of specializing in Creo Illustrate and TechPubs and Arbor Text, that kind of stuff. So Boundary is a technology leader. We are a PDSVISION Platinum partner, and we really aim to provide all-in-one solutions to anything relating to PDSVISION products. So that includes providing licensing, maintenance, consulting services, training, in addition to data management solutions. Just moving on a little here. We've won numerous industry awards. As I mentioned, PDSVISION Platinum Partner, Preferred Service Provider, and Authorized Trainer of lots of different software, mainly Creo, Windchill, and Arbor Text. Lastly, about Boundary, although we mainly work with PDSVISION products, we do use lots of other different software that kind of serves to fill in some gaps in the functionality that PDSVISION software provides. You can see some of this software we also use on our screen. This can include Keyshot, which is a rendering software creating realistic images. This is actually incorporated partially into Creo using some of their technology. And Moldx 3D, which is pretty exciting molding software. Without further ado, I'm gonna move on to shrink wraps. So first, a little bit about what shrink wraps are. Essentially, a shrink wrap is a collection of surfaces and datums that's used to represent the shape or space requirements or represent the exterior shape and appearance of your model. The reason you would make a shrink wrap, the main one is just to create a lightweight version of your model. If you were working with a very big assembly, you usually aren't going to need all of that information that assembly has saved with it every time you're working on it. So a lot of people find that work with very big assemblies, they can experience long load times every time they need to regenerate their parts. And just importing these assemblies and assembling them, running various operations can just be a bit frustrating. So one of the primary uses of shrink wraps is just the ability to create lightweight models and really bring in and use these models you make without using so much data. So it's a little bit more on that. a potential use would be, for example, if you have your model and you're trying to just figure out packaging for it, so you need a space requirement, but you don't necessarily need all the data about how that model is made. This is a perfect application of a shrink wrap. It can completely show all of your packaging or space requirements for a part without actually having all that data. Similarly, you can make a envelope simplified rep, and essentially you can seamlessly swap between your main model and your simplified representation that only shows part of that information. The next potential use is to eliminate proprietary detail. So if you want to send your model to another company, maybe a manufacturer, maybe a supplier, maybe somebody you're collaborating with, but you don't want to send them the file itself, because that would pretty much reveal its entire design. Not only the design process, but everything that went into making that. Oftentimes that's proprietary, and those are extremely valuable assets for your company. One of the things people often do is make a step file, especially if you're working with another company that uses a different CAD software. It's true that will often remove a lot of this proprietary detail. However, if you're working with somebody else who also uses Creo, you definitely have a much greater risk of those files being damaged, or through these various encryption processes. A lot of times, certain surfaces or parts of your assembly will not load properly or encounter some errors. So by using a shrink wrap, you can essentially accomplish a lot of the same goals that you would have using a step file, but you're still using your actual Creo model, so you're still going to have that data, and you won't have to go through that process where you're potentially losing information. And the last use is to create simplified reps. This kind of relates to my first use, to just create a lightweight version of your model. It can be a little bit different, essentially because it allows you to load a specific rep right from the get-go. So for example, if I create a lightweight version of the engine showed there on the right, I can actually just go to File, Open a specified simplified rep of that. So when I go ahead and open my model, it'll only be pulling in that data that is included in the shrink wrap. It'll be a much smaller model. It'll be easier to work with. A potential use of this is you could have lots of different representations depending on what you're doing. So for example, if you have an entire motorcycle, you could have you could perform a shrink wrap of just the engine, for example. You could exclude a lot of components very easily, and as a result, you could swap between all of these simplified reps that would maybe include different snippets of information that you might find useful. The main goal here is to reduce the size of the file, the model that you're working on at any particular time. And that's very easily, you're very easily able to accomplish that with the various settings that Creo gives you. So next, before talking about how to go about creating these, I'm just going to highlight a little difference between Shrinkwrap features and models. These essentially work the exact same way. The only difference is a Shrinkwrap feature will just be a feature in a part, much like an extrude or a hole or anything like that. It'll show up in your model tree as a collection of surfaces and datums, and it won't be a file itself. It's a feature. But another thing you can do is just make an entire Shrinkwrap model. So if you have an assembly file or a part file, something like that, and you would like to shrink wrap that entire model to maybe send it to another company, you can do that too, and that would actually create an entirely separate file. So that would be essentially just be created a little bit differently. And there's just a couple little differences which I'll show shortly. Main difference is dependency options. If you save as a separate file and then you make changes to that original, they won't be updated automatically. So it's not dependent in the separate file. Whereas if you make a feature, much like other features, it does have the option for dependency. So that's an advantage of a Shrinkwrap feature versus a model. If you're using it to aid in your design process, just make your model a little bit simpler, then you may want to use a Shrinkwrap feature because you can still make edits and all your Shrinkwraps will update. But if you're sending something out to a supplier, then maybe you just want to save it as a separate file. All right, so jumping into how to create Shrinkwraps. First, I'm going to cover creating Shrinkwrap features, and then I'll talk about Shrinkwrap models, which are those separate files. Creating a Shrinkwrap feature is pretty simple. Essentially, you have some options, including which components you want to Shrinkwrap. So if you're in a big assembly, just right off the bat, you can exclude a lot of those components in your assembly. So with my whole motorcycle example, I could exclude everything but the engine there. And that way my Shrinkwrap feature won't even have that data from those other features in it at all. So from there, once I've chosen the components I want to Shrinkwrap, Creo has various ways of collecting all of the surfaces of whatever I'm Shrinkwrapping, and then turning that into the Shrinkwrap feature. As I mentioned, Shrinkwraps, they don't include all of the data of the original model. They only include the surfaces and the datums. So there's a couple options to get Creo to select all those surfaces. You can just have it copy all external surfaces. You can have it pick up all solid surfaces, so all surfaces that are part of that create an enclosed solid geometry, or you can just manually select all of your surfaces yourself. I'll get into a couple more options when I actually demonstrate, but most of the time, the default that Creo will use, it'll kind of pick up all the surfaces on your model by default, and this process will be fairly easy. Creating Shrinkwrap models is also pretty easy and straightforward. Instead of just clicking a button in the ribbon to create a feature, you're just going to use File, Save As. And from there, there's a drop-down that you can save as a Shrinkwrap rather than whatever other type of file you would like to save as. From there, you will a window will open up with lots of different options to make that Shrinkwrap model. Among those options are the type of Shrinkwrap model that you want to create. This has some additional functionality versus Shrinkwrap features. Whereas features, you can only make them with a selection of surfaces. You have two additional options when you save it as a separate file and make a Shrinkwrap model. You still have that surface subset option, which will select lots of surfaces from your model and make a Shrinkwrap. You also have the faceted solid and merged solid options. Faceted solid essentially starts with a rectangular box, and as it gets more and more accurate, it will add sides to that box and kind of conform to the geometry you're making a shrink wrap of. This can be a little hard to visualize, but if I just jump to my next screen here, this is a picture of this faceted solid. So essentially how it works is it creates a big solid block, and as I said, it will add more and more surfaces to this mesh to get closer and closer to the initial geometry. And the last method is a merge solid. How this type of shrink wrap works is it will actually merge together all of the components of your assembly, and it will then combine them into one solid components. This will be generally the most accurate type of shrink wrap because it will be essentially an exact copy of the geometry of your initial model. It will, however, take the most time to generate and take up the most file space. All right, so that covers the theory of shrink wraps. So with that, I'm just going to go ahead and jump into actually creating some shrink wraps. So first thing I'm going to do is just open up a engine assembly feature here. So we can see that this is an engine. It's actually part of a blower assembly, and there are lots of different parts and some assemblies, some sub-assemblies rather, included in this engine. So first thing I'm going to do, I'm just going to quickly change the model tree filters to include features. Looks like they are already included. That is good. Okay. So next what I'm going to do, I'm just going to create a new part. I'll describe the reason I'm doing that in just a second. But for now, I'm just creating a new solid part. Just going to choose the right units as a template. And I'm loading this new part into my assembly. I'm just going to quickly give it a default constraint to lock it into that assembly coordinate system. Click OK to create that new part. Now the reason I did that is when I go ahead and assemble this, I'm going to create a shrink wrap in this part. So that will allow me to create this part feature in this new part I have. But I will be able to select various components from the assembly to either include or not include in my shrink wrap. So when I activate this part, you can see that my model tree changes and I have this, or rather my ribbon changes and I have this shrink wrap option. So up in my ribbon, first you may notice this subset button. So when I go ahead and click this, you can see my main assembly here up at the top and a list of all the components and sub-assemblies that will be included in my shrink wrap. So I'm just going to go ahead and select a lot of these internal components that I'm not too concerned about, and I'm going to ignore them. So just to show that a little differently, I'm going to change this graphic window to only show what's being ignored. And we can see that I'm just removing a lot of these internal components that I'm not concerned about for what I'm going to be doing. I'm mainly concerned about creating a simplified version of this model to gauge the size of it. So I'm just going to leave all this out. So going back to what's being considered. There we go. That looks good to me. So I'm going to click OK. The next thing you may notice is this drop down. We have 3 different options here for the collection of surfaces. We have outer shell, which will automatically collect the outer shell of surfaces. We have auto collect all solid surfaces, which, as I mentioned, will collect any kind of surface that's part of a solid. And we also have manual collection, which will allow you to select all the surfaces yourself. If we open this references tab in the ribbon, we have some additional options to include datums and select certain surfaces to either always include or never include. If we move over to options, we have some additional options here. A couple I'm going to talk about. The most important is at the bottom here, which has to do with whether the copied geometry will automatically update with changes to the original model. I can select no dependency if I want my shrink wrap to never change, automatic update if I want it to automatically, or manual if I want to choose when. The level here is going to be the level of accuracy with which it creates the shrink wrap and gathers the surfaces. The higher this quality level, it's on a 1 to 10 scale. The higher that quality level, the more accurate your shrink wrap will be, and the less likely it is to miss any surfaces. I'm going to change this to 5 right in the middle. I just get a little notification that it'll increase my time and memory usage, which is okay for me. So next, what I'm going to do, I'm going to include auto hole filling, which will automatically fill in any holes or indentations. And I'm also going to turn on this ignore small surfaces. What this will do is will exclude any surfaces based on a certain percentage of my total model size. So I'm going to put 2 in there, and any very small surface that is less than 2% the size of my whole model, it's just going to be excluded. So with that, going to click OK. And we can now see that I have a shrink wrap feature created in this new part down here. All right. Now I'm going to pull open this part, which really only contains the shrink wrap feature at this point. You can see that this indentation, which appeared in my, if I go ahead and hide this, you can see my initial assembly has holes and indentations here, which were filled in due to the options I selected. If we go back to the part here and I'm just going to change the view around a little bit so we can see what this is. If I make this wireframe, we can see these surfaces and datums which were collected and added to my shrink wrap. If I just switch this back to shading and make a section going right through this model, we can see that none of these surfaces are solid here. They all just have basically a dimension of 0 in the other, in this case in the x-axis. So this really is just a very lightweight collection of surfaces. All right, so a little bit more on shrink wrap features. I'm just going to go in to edit definition to edit my initial shrink wrap. I'm going to switch this to auto collect all solid surfaces. I'll go ahead and exclude internal components. That's okay. So going back to my options menu, if I select this method of collecting the surfaces, you can see that my options actually changed quite a bit. One of my options here is to solidify the resulting geometry. So if I go ahead and select that, click OK, and then open up this part again. And with the same section, we can now see that the shrink wrap is now solid. So what it did is it collected all of the surfaces that make up solid objects in my model, and it went ahead and solidified them. So in that way, this is still a collection of surfaces and datums. And as a result, even though this shrink wrap appears solid, it actually will not have any mass or material information applied to it by default. It is still meant to be used as a very lightweight collection of surfaces, not necessarily for the applications of any kind of mass calculation. Okay, excellent. So now moving on to shrink wrap models. I'm going to open up a very similar engine part here. And this time, what I'm going to do, instead of creating a new part in this engine and then creating a shrink wrap feature, I'm just going to save this entire thing, and I'm going to save a copy as a shrink wrap. So to do this, really simple, I'm just going to go to File, Save a Copy. So we can see this folder I'm in. This SW model is my initial, and I'm saving it as an assembly. So I'm just going to use this scroll window, select shrink wrap, and you'll see that I have a new file name that it'll prompt me to create. I'm going to make this just 0008 to make sure I haven't already done it and I don't run into any errors. And okay. Now when I do that, we'll see that I have this additional option window on the right that pops up to go ahead and save these shrink wrap files. So at the very top, we have surface subset, faceted solid versus merged solid. As I mentioned, surface subset works exactly like the shrink wrap features we've just looked at, in that it will gather a collection of surfaces and create the shrink wrap that way. This will be the lowest data usage method of creating a shrink wrap versus these other two that are only available when making a shrink wrap model. This will generally be lowest data usage. It'll be the fastest, but as I mentioned, it will only include the surfaces and the datums. So it's a bit limited in that regard. Once again, we can see some similar options here, such as fill holes, ignore quilts, ignore small surfaces with that threshold as a % of model size. You will notice that we can assign mass properties in this shrink wrap model interface. We cannot do that by default with a shrink wrap feature, but if you're saving it as a shrink wrap, you can do that. Another neat feature that we have here is the ability to preview. So if I go ahead and click preview, we can see how this shrink wrap will look. As I mentioned, this is a surface subset, so it is looking to gather a collection of surfaces. We can also see that this is not perfect. I left the quality on level 1, and as I mentioned, that will mean it's more likely to be more deviated from our original model. It's more likely to actually miss some of the surfaces. So I just adjust this quality to, let's say 7. I can preview this again. And you may have noticed it took just a little bit longer. This is not too complex of an assembly, so it just took less than a second really. But as a result, we're able to get a much more accurate looking shrink wrap. So okay. I click OK there, and it'll leave this window open, but it tells me down in my message window that my model has been saved. So next I'm going to make a faceted solid. I'm going to make this one 0009. Once again, to make sure I don't make a duplicate there. So to demonstrate how these faceted solids work, I'm going to put the quality to 1 and go ahead and preview. As I mentioned, the way this works is it basically starts as just a big block, and the higher level of quality, the more surfaces it will add, and as a result, the more detail it'll get, much like creating a mesh for CFD or something similar to that. So as I bump the quality up here, and go ahead and preview, we can see that this gets better and better, more and more closely related to my original. I'm gonna go ahead and save that. Lastly, I'm going to show merged solid. So as I mentioned, this will be the most accurate type, but will take up the most data, take the longest to create. So I'm going to leave this quality on 8 and just preview. What this does is it just combines every part in my assembly into one big solid shrink wrap. This will, I know I keep saying that it's bigger than the other types of shrink wraps, but this is still extremely, extremely lightweight compared to the entire assembly. All of the different references or relations or dimensions that are used to make all of these features in the assembly, all of that data is no longer needed when you create a shrink wrap and combine all this together. Fundamentally, it's still a collection of surfaces that it's just a lot easier to store than the model itself. So with that, I'm going to click OK. We can see this actually takes quite a few seconds, 5 or 6. Still not much of a problem, but just to show the differences between these methods, it's a bit different. So now I'm just going to go ahead and open these up and see what we have here. So first we have our surface subset. We go change our view to wireframe once again. We can see that we have surfaces and datums. And if I do a cross-section view, once again, we see we don't have solid geometry here. All right. Now if I go ahead and open up faceted solid, this will essentially appear as a big solidified block. So if I change this to wireframe, we see all of these surfaces kind of around the edge that are created. Back to shading and view. And essentially, this is a big block. The external geometry is going to get closer and closer to how this looks in the real world, but with the faceted solid, the internal geometry is essentially completely ignored. Lastly, we have the merge solid option. So essentially, what this did is combined all of our parts here into one piece of geometry here, one collection of these surfaces and datums. As a result, this is going to be more accurate than any other method. So let's just go ahead and show what's going on here. You'll see once again, you kind of have these surfaces and datums collected and created. We go to our planar cross section here. We can see that this is mostly filled in. There are it looks like it did actually pick up on a couple surfaces here from merging these solids together. But in general, this is as I mentioned, you're not using this to make computational measurements. You're using this to make a lightweight version of how your model looks. Okay. So with that, I'm going to open it up to questions. So I will give you all a just a minute or two to go ahead and ask away, and I will let you all know. All right, so let's see. First question we have, or rather concern, I guess, looks like we were, for part of this, the screen sharing looks like a bit behind, 20 or 30 seconds behind the audio. So sorry I didn't notice that before, and I'm sorry if that caused any problems. So moving on to next question. Noticed that with fill holes checked, the shrink wrap still had some holes. So let's take a look at this real quick and see if I can and see what you mean here. So I'm gonna just erase not displayed, open this back up. All right, so we're just going to make a shrink wrap of this entire assembly. We're going to autofill holes. Okay, and then we're going to open this up. Let's see what we got. As far as holes go, if you're referring to these kind of gaps that we've got here, essentially what this will do is it'll miss some surfaces, and it won't automatically create kind of a conjoined solid unless you choose that option to select all solid surfaces. As far as that fill holes option, what that will do is it'll essentially try and fill holes and indentations in surfaces. Whether that is always foolproof, I am not entirely sure. I don't think I've had any problems with just kind of the basic holes and extrudes being filled. The main thing I would say to that would be if you are selecting all solid surfaces and filling that geometry, then you won't have any of these kinds of holes. But if you're just doing a surface subset, then I would say I wouldn't expect to have all these surfaces be joined together in a continuous way. All right, let's see. Is a shrink-wrap file always a part, or can it be saved as lightweight assembly? Can any parameter values be exported with it? So as far as I know, I'll look into this. As far as I know, everything I have done, the shrink wrap will be saved as a part. If there's a way to do that, I will go ahead and find out. But my first reaction there is yes, it does. Shrink wrap file does have to be saved as a part. As far as parameters exported with it, yes. I don't know that I can go ahead and say I've tried that with a part with just a shrink wrap in it, but I see absolutely no reason why why parameters wouldn't be included with that. Essentially, it will work like a part file, and as a result, I can't imagine there would be any problems with that. Let's see. Next question, are there any fundamental changes from Creo 4 to the current version of Creo? So current version, just for everyone's information, is Creo 7. As far as fundamental changes in general, yes, there are quite a few. The biggest things that Creo 7 has added are firstly multi-body design. I'm not going to get too off topic here, but multi-body design is very big. There are a lot of other big features that came with 7, and several that came with 5 and 6 as well, although maybe not as major. Regarding shrink wraps themselves, not really, no. This still works the exact same way in at least Creo 5 to 7. There really haven't been any functionality changes to shrink wraps as far as I know for that time period. All right, let's see. Does the custom unit from the original assembly transfer to the shrink wrap parts? So I believe what's being asked here is when I went ahead and created that part, so this part right here that I put the shrink wrap in, I kind of loaded I created that from a part file that had certain units already selected that were something like millimeters, kilogram, newtons, whatever that is. So the question on the custom unit from the original assembly transfers to the part, I am actually going to say no. As far as I know, if that feature is created in the part itself, it would use by default those units. I would assume. That is a good question as far as whether if the units in your assembly are different, if that would be if you'd be prompted to convert that. And I'm not sure I have an answer to that right now, but this one I am going to go ahead and copy and get back to you on that. All right, another question. My step files, import exports, collapse. So I have to shrink them first, then send them out as step. So I do know people that do have some problems with step files. So essentially, you're saying you have to shrink wrap them and then send them out as step. So I'm not sure I completely speak to the issue of why the step file export import is not working. As far as why shrinking them first might work, the files are definitely smaller, simpler. They're a collection of surfaces. So I imagine that that potentially why your step import export is not working is due to the size of your file. I'm really not sure without knowing the specifics. Just kind of a random guess by me. I know I've had problem when I have slow internet with having certain files not download properly. Looks like we also have a comment here by somebody that says file name might also have spaces, so that potentially could also be a problem there. But those are just some things that come to mind with me. All right, I said file sizes are smaller. Can I show an example of file sizes compared to the original? Yes, definitely. So let's see. This file browser is probably what I want. If I open up the folder that I was in before and save these various examples in, so let's see what we got here. We have, well, it looks like we have the assembly file, which has a whole lot of different part files as well associated with it, which is why this size here would be so much smaller. As far as examples of maybe an entire assembly, the how big that folder would be. Let's see if we can go ahead and save as right here and see if we can figure that out. And otherwise, I'll get back to you on you know, some approximations on how much smaller, etc. Let's see if we can find out real quick. So if I go to folder, I'm just going to make a new folder here. Okay. New file name. And let's see, we want, forgive me, I'm trying to remember how to make sure all of this gets saved. I believe that is by default. Saved as copies. Save copy, okay. Looks like we just got the assembly. I'm going to look into that question and get back to you just with some approximations on how much smaller a shrink wrap would be exactly, just because I'm not able to see it quickly right now. But it'll definitely be substantially smaller. If I had to guess, it should be definitely you know, a fraction of the size, just due to the amount of features. But as far as specifics, I'll have to get back to you. All right, let's see. When working with a merged solid shrink wrap, it can be very difficult and tedious to join the components with protrusions prior to creating the shrink wrap to ensure you end up with a solid part. Do you have any tricks? Okay, so I think what I'm hearing is essentially it is hard to make sure all these components are connected, so so that the part correctly joins, or that rather the assembly correctly joins all of these parts together to solidify. Do I have any particular tricks? As far as with merge solid and how you go about assembling that, I'm not entirely sure I have any good tricks for that right now. I think I need to look into kind of dig farther into that and try and find that issue, try and run into that issue, and go from there. So short answer is no, not at the moment. But I will try and identify that problem you're having and see if I can learn more about it. Let's see. Can you shrink wrap with axes and select a bottom surface to assemble shrink wrap to a mounting plate? So to the first part of your question, can you shrink wrap with axes? Can you include axes in a shrink wrap? The answer is yes. And can you then assemble a shrink wrap to align to a mounting plate? That's also yes. So as I mentioned, you can create a shrink wrap as basically it would be a feature in a part. So you can just go ahead and assemble that into an assembly how you would with a part normally. This is definitely possible and useful to do. Let's see what else we got. Is it possible to skip creating a part first in an assembly? It seems like an extra step. Can you create a shrink wrap in an assembly without creating a part of the assembly first? I think I kind of covered on this. I think the answer is no there. As far as creating that feature in an assembly, as you may know, a lot of features can be created in assemblies, but many cannot, and they're specific to parts. As far as I know, there's no way to create a shrink wrap feature native to an assembly file. Looks like we just got a couple more questions. Can a shrink wrap model be related to the actual part and be switched out back and forth as needed? Breaking that into a couple pieces, can a shrink wrap model be related to the actual parts? The answer for that is actually no. So shrink wrap features, which are contains as a feature in your model tree, these can be dependent. So when you change essentially when you change something in your initial, your shrink wrap will saving it as a separate file, a shrink wrap model. There's no way currently to make those associative, make those update automatically. To the second part of your question, whether you can make that be switched out back and forth as needed. Yes, this you can definitely do. So if you create a shrink wrap feature, as I showed by creating a shrink wrap in a parts, if you go ahead and do that, you can actually create a simplified representation, which I definitely talked a little bit about, but didn't exactly show and cover. So in this view manager, the same way you would create an exploded view or a specific orientation if I wanted to, for example, lock in this kind of zoom in view. In that same way, I could create a simplified rep. Essentially, I could just hide everything except for that shrink wrap feature when I'm creating my simplified rep. And as a result, that simplified rep would just be my shrink wrap. So switching back and forth would just be as simple as swapping between my representations. All right, last question. can shrink-wrap models be used in assemblies? Or are there restrictions on mating? The answer to that is yes, they can be used in assemblies. As far as restrictions on mating, I can't guarantee that it would always work in the exact same way due to just the difference in references that you have. Since, as I mentioned, a shrink wrap will just be surfaces and datums, the mating might be a little bit finicky there. As far as all the specifics, depending on the type of connection you're going to use. I'm not entirely sure of all the interactions there, but as far as assembling with shrink wraps and mating, definitely doable, definitely works. Just you may have to keep in mind what a shrink wrap is and how that would restrict you. All right. So there were a couple questions that I'm going to dive a little bit more into, and I will send you all emails for follow-up. Looks like I have headphones issues. Hopefully everybody was able to still hear me. If anybody had troubles hearing any of my explanations there, need additional clarification, I'm so sorry for the technical difficulties of cutting in and out. But just to give people a last chance to ask any questions here. And if we don't have any, then we can call it. Oh, looks like I did get a really good question here on something I didn't cover. So going back to my PowerPoint, the question was, where will this recording be available? All of our webinars will be available on our YouTube channel. So that is, you can find that just by Googling Boundary Systems YouTube. Additionally, as I mentioned, I'll follow up on questions, but if you think of anything else after this, then my email is right there. It is sbeaver@boundarysys.com. And feel free to shoot anything my way. The sales email is there as well if you're interested in any kind of training or licensed services. And as I mentioned, all of our webinars can be found on our YouTube channel, which has a big library of information on Creo, and I would encourage everybody to check it out. All right. Thank you so much, everybody, for attending. I hope you learned something today about creating shrink wrap models, what they do, what they can be used for, and I hope you all enjoy the rest of your week. Thank you.